Hi everyone. Last time we looked at the difference of squares, and now we're going to look at an example where we have a perfect square. Now in the perfect square trinomial case, we use this particular identity, namely this observation that if I have a plus b whole squared, right, what does that really mean? It means a plus b times a plus b. Now in this case, when you FOIL out a times a times b, a squared plus ab, the b times a is no longer negative, so it doesn't cancel out. Instead, it gives you a squared plus 2 times ab plus b squared. Okay. Similarly, if instead of the plus version, I had a minus version, this would be a minus b times a minus b, which, when you do the same thing, now you have two negative ab's instead of positive ab's, so you get a squared minus 2ab plus b squared. Okay, so if you think about it, last time we had an a plus b times an a minus b, and that's why these terms were getting cancelled, right? So now the natural question, I guess, is to ask, like, what happens if both of them were a plus b, or if both of them were a minus b? So that's what happens. So in this case, how we're going to use this is, you see this, and from here, so you go in this direction. Like, you try to recognize something that looks like that, and you go back to the factored form. Okay. Let's see if we can do area thing for this. So a squared plus 2ab plus b squared means I have one square, which is a by a. Then I have two rectangles, which are, let's say, a by b's, and then I have two, let me make this what, like that, a by b, and then I have a b squared. So I'm trying to build this into a bigger square. So one way to do that is, I take the a by a piece of material. There's two of these, right? So I take one of them and I put them like that, and I put the other one like that, and then I fit in this guy in here, and I get a square. Now what's the area of this square? The side is a plus b, a plus b, a plus b, a plus b, so it's a plus b whole square. Okay. So using the area method as well, things work out pretty much fine, which makes sense because we've already seen this using algebra. So obviously using the area method should not be giving me any different result. Okay. Now, because in this case we have to go back, what we need to keep in mind is if we can see, so remember how for the previous case, you look out for these numbers and a subtraction and two terms. Yeah, that gives you an idea that it might be difference of square. Here, you look out for three terms, and you look out for something of the form 2 times a times b. That sort of gives you the hint that it might be a perfect square. Okay, so let's look at some examples. X squared plus 49x plus 14x plus 49. So the first hint is that first it is a trinomial. So that's a good deal. So you can always solve this by splitting the middle term, but you can also do it directly by observing, remember from our list, that this is actually 7 squared and 14 is actually 2 times 7, which means you can directly factor this as x plus 7 squared. This plus because it's plus 14x, not minus 14x. And you can verify that by saying that this is x squared plus 7 squared plus 2 times 7 times x, which is 14. Now, while sometimes it may be easy to do it directly, some other times it may not be that easy. So let's look at an example where it's not direct and easy. Okay, so the non-direct case is right here. So I have a trinomial. Okay, now what I'm looking for, what is the pattern? The pattern is something squared, some other thing squared, right? Say square, triangle. And here it's the product of these and 2 times. Now this could be plus or minus, and this is always plus. So what I try to do is I try to write these as squares first. 4 is easy. I know 4 is 2 squared. Now here I observe 9, which I know is 3 squared, and a y to the 4, which I can write as y squared squared. So this is similar to an example prior where we had 81x to the 4. Okay, so now I have the square of two things. Now let's look at this middle term. What is 2 times 3y squared? That's 3, 6, 12. So this is 12y squared, which matches up with a negative sign. Now because it's a negative, this means this is simply 3y squared minus 2 whole squared. Okay. Just as in the previous case, since it was positive, this was positive. So this sign and this sign are always the same. And here, because this is negative, this has to be negative. Now let's look at an example which is slightly more complicated in the sense that this combines two methods that we have learned. So first of all, it's different because I have 4 terms and there is no GCD stuff happening here because there's a y squared and all of this. So what I do is I look at the first 3 terms. Right? In the first 3 terms, this is x squared, this is 4 squared, and what's 2 times? So on the scratch here, 2 times 4 times x is 8x with a negative. So that's good. That means this falls into a perfect square pattern. And then I have separately negative y squared. So just the purple part, that is going to be x minus 4 squared. But it's not complete because I still have a y squared. But what is this? This is difference of squares. Now because this is a difference of squares, it is x minus 4 minus y and x minus 4 plus y. So at the end of the day, it turns out that even though there's x and y terms involved and there's no GCD that can be taken, it can be factored into product of 2 terms. Now at this point, you may want to pause the video and try to do this second problem. Wait, let me check. Yeah, try and do this second problem in the same way, but maybe I do one step for you here. And the step is that there's an a square, but there are 3 terms involving b squared, which means you should try and focus on working on these 3 terms. And you can rewrite this as a squared minus, so take out a negative 1 common, so b squared minus 10b plus 25. Now pause here and try and see if you can work on this blue term here, just like we did with the purple one. All right, hopefully you tried it. So here we observe that this is b squared, this is 5 squared, and this is exactly 2 times 5 times b, which means this whole thing can be written as b minus 5 squared, but then don't forget the a squared minus. Now again, right here, you can apply the difference of square to get a minus. Now here you have to be careful because you're subtracting, so maybe keep the parenthesis, a minus b minus 5 and a plus b minus 5, so that in the next step when you distribute this, this becomes a minus b plus 5 and a plus b minus 5, which becomes your final form. Okay, so you can have a very basic example, and you can have slightly complicated ones where you just need to remember the squares and the pattern that 2 times the product of these things is the third term. And then lastly, you have these forms where you cannot use any other method because there's x and y terms and the y is by itself, or there's a and b terms and the a is by itself. So in that case, what you do is, for just the x terms, you try and express it as a perfect square if you can, and then it will turn out that it's actually also a difference of square, which you already know how to factor. All right, so that's the part which is a perfect square trinomials. That's the end of this video. Next video, we go ahead and do a couple more special forms of factoring. Thank you.